Hello everyone, how are you all? Welcome back to the another video. I hope all are you good and learn something new with day by day, right? Now after a long time this video will become, then sorry about this because I have a little busy with my students, right, with my course related videos. Also there are a lot of works on my table, so that's why this is the reason the video will late. Now we have a study case on my table. Right now this is a Samsung based phone, right, a Samsung 151, a Samsung M51. Now this phone come to me in a dead condition, not turning on. I'm already open the phone, right, completely dead. Right now when you look at the front, right, someone remove the shield and there are some work on it, right, like a heating purpose. When you look at the other side, right, there are also someone remove the cover, not the shield, just cover, and heat up the CPU. Because if a dead phone come to you, the normal technician, or you can say the normal shopkeeper, do fun thing, right, they heat up the motherboard. They try, after heating up, by chance this phone turn on, they will make money. But nowadays whatever the phone CPU will be a fully glued. If you heat up, or you can say the excess heat on the motherboard, right, sometimes the CPU collapse internally, CPU dry soldering. So don't do this. So if you want to be a pro technician or you are a professional repairer, this stuff are hitting without knowing anything, this is not a good repairing skill, right? For this there is a process. For any repair there are systematic way to repair any device. We call a systematic repairing. There are process, right? For this process you have to know each and everything about the circuit, how the circuit work, each and every line, as you seen in our videos, right? When we repair any study case, we repair according to the systematic way, according to the process, a step by step. Also in my videos on a theory class, I will share with you all the information about the diagrams, about the circuits, how the circuit work, which line for the which purpose. So in a practical time, when your theory is strong, your work will be easier, right? If you do not know about the theory and do it like directly on a practical basis, you will be harm the phone, right? So the schematics is most important tool. If you want to be a pro, every pro technician understood the schematics, how the schematics work, and according to the schematics how to repair a phone. Or if you want to be a pro, a professional repair technician, the schematic is a must, right? Because at 70%, even 70 to 80% are schematics. When you know the diagram, when you know which IC for which purpose, or which line or which voltage rail for which purpose, and how to fix. After that 20 to 30% remaining is a hand skill. If you only know the hand skill, if you are only good at hand skill, you will be repaired just like replacing the ICs or revolve the CPU. Otherwise a normal fault come to you which has a small capacitor, a leakage capacitor, or you can say a resistance due to, or any line miss open, you can't repair the phone, you just replaces the IC. The schematic knowledge is a must. For this we provide the online courses, right? As you know, we provide the online courses, online classes. In this online courses, we teach you about the schematics, how the schematics work, how to work according to the process, a step-by-step preparing, each and everything with the proper detail, right? As you see in our study cases or the theory classes, in a full depth knowledge, all the details about the mobile diagrams. Also there is a festival season in India right now for the Diwali purpose, so I'll give you an offer for my courses. If you join within this month, right, before ending of this month, I'll give you an offer, a great offer. So in this offer I'll give you a 3-year validity. So if you want to join before end of this month, after the expire this, it means after end of this month, the offer will be closed, right? After this, your validity will be only for the 1 year. Right now it's for the 3 year. After that, the only for the 1 year only for is. So grab the opportunity. If you think I'm the right mentor for you, if you think I'm the right teacher for you, and if you want to update yourself, like from here to here, right? If you want to start your journey to success, to grab the opportunity and join the course before end of this month, right? Now let me talk about this phone, right? How to fix this type of the phone when it dead phone come to you. So first of all, we connect a charger. In front of you on the right side there is a charger connected, right? So when we connect the charger, there is a nothing, the flux is connected. All right, when I put here, there is a 0.006, I mean to say 60 milliamp, not nothing. If you convert on a 2-digit charger, normal technician used a 2-digit, you will see there is a nothing consumption, but this is a 5-digit. That's why there is a difference. We see a little consumption, right? We just remove this, and when I press the button, or you can say, sorry, I'm not connecting a charger still. Now we connect the battery. Now let me connect again charger. Still a same after connecting the battery and before connecting the battery, the same, right? Now when I press the on off button, nothing. All right, battery, no, this is unplug. Okay, nothing. Now I just remove the battery and check the first VPH. The VPH is available or not, right? So multimeter on it, DC voltage mode, right? On the top side right corner, right? And this is the PMU. In this phone you have seen a 2 PMU, 1 PMU, 2 PMU. The model is M51, M151 Samsung, right? And the Qualcomm chipset based on a Qualcomm. The Samsung used Qualcomm and the MTK Exonics, all the chipsets, right, according to the price, right? So this PMU, you can easily find the PMU. You have seen these buck inductors around them, right? So you can easily find out. Now these capacitor between buck and the PMU are VPH capacitor. When we click here, so there is a voltage -4. When we see here the 4 voltage 4.3, okay, that means the VPH is available, but phone still does not turn on, right? Now we diagnose a step by step, right? So we remove the charger and we start with the diode mode. Now we remove the battery and check here on the battery connector terminal, 416, and on a forward bias it's above 1000 plus or 1300, around that. So according to the multimeter, the battery connector is okay. The battery connector, a primary line, is okay according to the multimeter. Now after that we have to check VPH, right? The VPH is also made, that means the VPH is also okay. After the VPH, let me check the buck lines and around the capacitors, if any capacitor was short or leakage or any buck, right? So test one by one. This one 364, this is also okay. This one okay. 351 okay. Okay. 181 okay. 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 98 okay. And this one is 321, all okay. Now let me check on a secondary PM. There is a 47, right, and the beep. Remember one thing, in my all videos I'm always told you, in some lines, right, when you check there is a low reading with the beep, that doesn't mean these lines are short. I will explain you clearly. that doesn't mean this line is short. Under 50 ohms your multimeter beeps. Now this line show me a 47, that's why it's a beep. And this line may be any CPU core lines, application core line, right, a memory line. That's why these are the low resistance lines. Many times I will explain you, and my students already know this, right? So sometime student or sometime the technician confused when we see the beep, or you can say when we hear the beep, that means there is a short, and they inject the voltage, and this line 100% connected with the CPU. When you inject the voltage without knowing this line, right, let's say this line had a 0.8 voltage, a default voltage, and a 1.2 maximum, and if you inject a 3 to 4 volt for thinking there is a short on this line, a PMU short or any capacitor, you can find a shorting easily. In a starting time, mostly technician, in a beginner, as a beginner, mostly technician do this thing, and they inject the high voltage to find the shorting, right? When you inject the high voltage on these lines, right, your CPU internally short, or you can say blast, because these are core lines, these are some low resistance lines. So never do these things, right? I will clearly explain you each and everything, whatever explained by in a coaching centers, or you can say the institutes. I will all try to give you all knowledge or share you all knowledge in a YouTube, right, in a detail. So never do this, right? Now next, on this side there is also a beep and the 10. So these lines are doubtful. Now I check with this multimeter, right? 395, okay, 416, 416, 396, okay. So these bucks on this PMU, all bucks are okay. Now we test this. So 72, it's okay. 26, now this buck is a low reading, right? Now this is the difference as we measure this multimeter, because I have doubt on this multimeter before I using. Now we use this multimeter, right? And there are some difference when you use a 2 multimeter. You will see there are some different, because I've doubtful on this buck, right? This buck give me a 10 ohm reading, right? So I'll be confused. For this I'm using a different multimeter, and I'll give you a suggestion. If you are a good technician and you love the tools, minimum 2 multimeter on your desk, because sometimes if a multimeter give you a wrong reading and you have a doubt anything, for the confirmation the another tool, the another multimeter must on your table, right? So we check with this, because the every multimeter gives you a different reading, but according to your experience you will know. But for the confirmation you have to need another multimeter must. Now we check with this multimeter, right? Now on the first power 396, it's okay. On this side, okay, 416, this one okay, this one okay, 212. Now check this, okay, 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 345, this one is also okay, 396, this is also okay. When we check here on this buck, let me zoom so it will be a clear for you. Now check here. Now that will be a fine. Now look at here, 0072. Okay, now '72. Before, when we check with the desktop multimeter, right, on your right side upper, this will be give you a 47, right, with the beep. Now it's a 72, so there is a difference. Now this buck give me a 10 reading, but now in this 26. Now as I told you, some lines are low resistance lines. If any buck gives you a 000 or 00 under 5, minimum of 5 ohms, then you have to doubtful, or you can say the proper thing, this line is a short, right, because these are low resistance lines. Now 26 and these two are in a similar, these two coils are in a similar line, like in a, you have seen in a APC. I'll show you in a schematic also. In a APC core lines, there are two lines, two buck lines for the generating the high ampere, connecting in a parallel. Now on this 33, on this 340, okay, 340, 340 and 379, okay, this 440 and 375. So all the bucks are also okay, the VPH is also okay, the bucks are also okay, right? Now we check the buck voltages, and after, let's move on step by step, right? So we clear the zoom here a little bit. So we connect here a charger, right, and the charging starts here. Let me check the first. There is a VPH on a voltage mode, okay, multimeter on a voltage mode, 4.3, similar voltage we've seen in a different multimeter. Now here on this buck, no voltage, on this no voltage, here no voltage, right, no voltage on this. 1.3, okay, the 1.3 we get a 1.3, one of the buck had a voltage 1 volt here, and 0.3, okay, okay, no, so we have only a 2 bucks, 1 volt and 1.3 volt. Now on this buck there is a no voltage here, right? Let me zoom it. So on this buck, nothing, 4.3. so this is a VPH buck for this IC, right? All the other bucks are no voltage. According to the diode reading, all are okay, but when we check the voltage on the buck line, right, there are 2 bucks on a secondary PMU. This is the first PMU, this one is the secondary PMU, right? The secondary PMU 1.3 and 1 voltage are generated, but the first buck, I mean to say the first PMU does not generate any voltages. From here we need a schematics, or we do one thing also, we check all the randomly caps around the PMUs. Maybe we have found any fault line, right? Now some lines are also connected to the low resistance lines, like these lines which we have a low resistance lines connecting with the CPU. So still you have to think when you check any cap which has connected in a low resistance lines. Now these caps comes in a bunch, like on this area, so you have to sound a beep in a multiple capacitor. So you might be confused, there are short on these capacitors, right? But I tell you again, you have to find the line first, which line is this. If this line connected to the CPU and there are some APC core memory, like these are the lines for the right, then do not inject directly on the voltage. You have to confirm this line is short or leakage or not. We check randomly first with the multimeter. So we remove the charger here, a multimeter on a diode mode. 391, 39, this at 0, right? Okay. So one of this cap, I think we have a short 003, and this. So this cap we find a short something on the corner, this one, and this is okay. Check again. Okay, this is I think short 372003. This cap is also short on the both corners, right? And 460 around the PMU. These are all okay. This one, there is nothing. 396. Okay. 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 Now we have found two capacitors over there. They are short, right? Let me check again. Okay, before it's 376, this one 005, yes, 003, and this one. Now check the under the microscope once time. So these caps are short. Okay, now let me switch the same multimeter previous. This is a short. Okay. Okay, so 1 and 2, these two are short, and these capacitor connected this IC. So we open the schematics right here. Let me open the board now. So there is no schematics available. So how can we diagnose? Now there is a bitmap here. Let me open the bitmap and see the capacitors. Right, first. Now Samsung had many models. There is no schematics. So just open this, and now I think these first one and the third one. This is a 1.05 line and connected here. Okay, to this IC. This is a camera related IC. Okay. So okay, this one is a camera related IC. Now I do one thing, because these caps connecting on a different balls, right? Not in particular balls, not in a similar lines or different lines, but connecting on a similar IC, and there is a rear camera, right, a front camera. This one is a front camera, and this line goes to the, there is a rear camera. So this is a camera switcher, or you can say the camera related IC who operate the camera. So we remove this IC and let me check. These capacitors are short, one of or this IC, because chances are this IC, because the both capacitor are connecting on a different poles, and this IC does not relate to turn off the phone. Maybe there are chances, but most probably this IC does not relate to turn off the phone. I mean to say, due to this a dead. But there are exceptional cases, like if a line does not responsible for due to phone turn off, or you can say in a dead condition, but a similar line, if there is a shorting, or you can say there are chances, so due to this your phone does not turn on. And let me remove this, and after I will explain you. So we go to the microscope cam. So we remove this first of all, top camera. So we take a multimeter aside here, and remove this, remove all the accessory. Now we remove the, first of all, a camera IC. If your phone turn on, then the camera IC must be a short. If still there is a shorting remain, or you can say the shorting clear but the phone does not turn on, then there must be another fault also. Because if we remove the camera IC, the camera operator IC, it means that disconnect the camera relations. Let me explain you. First we do this thing, we just fix it, and okay, switch to camera. Now we remove this IC, right, and the direction on this side, the crystal side, there is a crystal out there, the direction on the crystal side. Okay, now we remove the IC. Right, now after cool down, we check the shorting remains or the clear. Right, the board is still hot. Oh. Now, before these caps, now we check these caps. OL, because there is no IC connected, and this side ground, and this one is also OL. That means the shorting, I will check you again, show you again. So this side is OL, before this side is PEEP. Due to IC this line short, right? Now we go to the microscope, and now we on the top camera. Now we fix the phone again, and let me see, due to camera tuner IC this line is faulty, or still there is a hot. we fix this phone here. Okay, and the battery. Now I'm connecting the charger here. Any changes here? Still same. Okay, still same. No changes. Still same. Now I'm check the buck lines. Any buck had a output. Multimeter on a DC voltage mode. No output. No output. VPH. Remove the battery. Okay, the VPH is here. Right. Now on a buck. Still the same situation. But the VPH is here. When we check the VPH, I'll show you in a microscope also. Now these are the so 4.3. the VPH on this cap VPH is available. Battery is still disconnected. No voltage on this, no voltage on this, no voltage on this, no voltage on the other PMU, no voltage on this, no voltage on this, no voltage on this. So nothing on this side. Still we have on this buck 1.3 voltage. Only these two bucks had a voltage, right, before the 1.3 and the 1.1 voltage here, but there is no voltage here. So now the situation is same. We have found two capacitors, but still we did not find it means the phone does not repair. The shorting is clear due to camera tuner IC, but phone does not turn on. The VPH, only we get a VPH. Now we trace this phone through the schematics. Now I will teach you something different, right? How to repair a phone, or you can say how to diagnose a phone which has no schematics. Right, now this phone had no schematics, as you seen in a Borneo, right? There is a diagram or bitmap only, but there is no schematics. But we need the schematics if we found this type of the problem, right? Which line for the which purpose and the proper. So we do one thing. In my every video previously, I'll explain you each and every detail. I'm told you every time, right? Whenever a phone come to you, work according to the IC number, right? Always told you work according to the IC number, not by the company model. Always work according to the chipset, right? There is a Qualcomm, MediaTek, and the number, the CPU number or PMU number. Now this phone has a 2 PMU in front of you, right? Now there is a 7150A, and there one is a, this one is a 750, sorry, this one is a 7150A, and this one is, must be a mistake here. This is a main PMU, right? 7150, right? We will see in a, right, and this one is A. Let me show you in a microscope. So this one 7150, all right, and this one is 7550A. Okay, so right, this is a secondary PMU. Now we open the another model. How we open the another model which has a similar IC? So similar, just copy this. You can do one thing here. Enable the PCD section, click here and click this IC. Now there is a list generate. over there. Now these all are the models which has a similar IC. Now this IC used in a pair, right? It means a 7150 and 7150A L B, these type of the pair, right? Now the Redmi models mostly had a full schematics. So we open the Redmi model and okay, Redmi K20, let's see. Redmi Note 10, you can open the Redmi K20, Note 10, any. Let me open the Redmi K20. So we go to the Redmi K20. There is Redmi K20. Okay, now there is schematics here. Just layout. And the schematics. Right, now we just layout right here, and we will go to the component section. First of all, I will explain you about this phone, the other things also. Okay, so this is, now you already know about these power IC. On the other side there is a Qualcomm based chipset 7150, okay, and there is a charging IC. This is a charging IC, but when you have seen a 2 PMU, already explain, or you can say my students already know this, the main charging IC internally, I will explain you a little bit, wait. Now which phone has a 2 PMU, right? Now in this model had a 7150 and 7150A, right? A Samsung M51, right? Now these IC always used in a pair, like 660, 660L, 8150, 8150L and the A, like this. Now A denote there is a AMOLED LED LCD, but we did not talk about this. So talk about this IC. Which phone has a 2 PMU, like in this 7150 and the 7150A. There are two charging IC also. One charging IC is Samsung related, right? Now the other charging IC internally on a main PMU on this, I will show you in a schematic also. There is another charging IC also internally fixed here, right? Now this PMU work as a charging IC plus work as a PMU, okay? So you have to understood this. Now there are a process to diagnose according to the schematics. We check randomly about these phones. We check the DC voltage, I mean to say, right? We check the charging consumption, right? I'm already checked through the DC power supply. There is a low booting, okay, but I could not show you on my screen, but soon on upcoming we will buy a new DC, a better. So after this, through the multimeter, no short, no leakage on this, but we find a shorting on secondary lines, like clear this, a shorting on camera tuner IC. When we remove the camera tuner IC, the short clear, but phone still does not turn on. All the bucks diode value okay, VPH okay, but buck has no voltage. Only one buck had a voltage, a 1.3 voltage, only one buck, otherwise there is no voltage, right? And all other around the PMU, all the caps now are okay, right? Now there is no schematics, so we open the another model, right? Our K20 Redmi. So we diagnose this and I will explain you about this. So clear this. Okay, now this is written on a power, but this is a charging IC. Now we go to the layout and how to diagnose a phone which has no schematic. Like this is a 2 PMU, similar 4200 and 4700. Just copy this and paste in schematics. And which PMU is this? Written here, like this is a PMU 7150. Now remember this is a different model, right? And this is a part, like sections. There are many sections. Sometimes it's in numeric on the written, sometimes it's in alphabetic, like A, B, C, sometimes a 1, 2, 3. So there are many parts on, or you can see the blocks. Now these blocks belong to the controlling section. You have seen these type of the supplies, like this is Xtel. This is a crystal exo connected, right? Exo connected with the PMU. You have must seen near the PMU the crystal. In this PMU you have also seen, I will show you, there is a crystal here. Look at here, a small crystal. I will show you in a microscope. Like this one, around this here there is a crystal here connected with near the PMU, okay, 7150. So this is the crystal, right? And there are, this is the on off switch line, right? A PS volt, already explained this, a power on reset line, right? A fault and line, SPMA clock data. So this section become a controlling section. There are clocks, sleep clock, BB clock, and there are some capacitors. So we check each and everything a step by step in a diagnosis process, right, for finding the fault. Now this is different schematics. How can we use this schematic to repair this phone? Like I will tell you the process. First of all, whenever a dead phone come to you, right, first of all you have to check what are the process with like with the charger consumption, right? Now this tool will also help you to find the fault, right, but not the result, just help you find the fault. After that there is a DC power supply. Now DC power supply gives you a lot of help while the diagnosis a dead phone, because sometime it will, if there is a short or leakage in a primary line, it's clearly tell you there is a short circuit. But if there is a shorting on a secondary, it's also told you, right, according to the consumption, a current consumption, a drop, this will tell you there is a chances, so work on it. If the reading is stuck so maybe a programming or software issue. So already made a video about a DC power supply, you can check out in my profile, right? Now after the DC, we check with the multimeter on a battery connector, right? Also a VPH. After that we move on to the voltage. So we take help all the tools one by one for finding the fault or better result. If you depend on one tool, you will be stuck sometime, or you can say sometime in a wrong direction, work in a wrong direction. So after that we check a VPH voltage, it's okay, right? Now check the BTST cap. Now in which phone has a 2 PMU? First of all, you have to understood, right, the V bus enter from the charging connector. Now this main PMU 7150, now this PMU generate the VPH, not the other IC. I will show you first of all this thing. I know my video is lengthy, but it will give you all knowledge. So we move on to the, but we check, okay, so we just copy here and we clear this. There are two charging IC, I told you. Now this PMU had another section. This is a GPIO section, common ground, LDO, buck, and this one is our charging section. As I show you, like this is PM7150, and you have seen this is a VBAT. There is a boot cap, right, the VPH generate and the coil. So this IC work as a charging. The other IC near the CPU, SMB or something, S2U or SMB, whatever, the IC work as a fast charging IC. The coordinate both. We will explain each and every line with the whole detail in our course, right? How these IC coordinate with each other, which IC activate first, and after that move on to the step by step, right? So it will be help you in a diagnosis. So basically I want to say this IC, we have to check this IC step by step, and after this we go to the further. Now one thing common, or you can say one thing remember, there is a no buck voltage on this. If there is a no buck voltage, there are many reasons, but one of the reasons